In this video, I'm going to build the light theremin project and then write the code with you. Some people were having trouble. Part of that was because I actually had a couple of mistakes in my project sheet, and some of you might have been having some other problems. So hopefully this will help. I have all my parts here that I need. I have a 10K resistor, my photoresistor, I have my buzzer, Arduino, and a small breadboard. So the first thing I'm going to do is I'm going to put my photoresistor on my breadboard. So stick that somewhere in here, doesn't really matter where, 2 pins apart. One side I'm going to attach to ground via my 10K resistor. So I'm going to drag that into position there. So this is attached to the ground rail and to one side of my photoresistor. The other side of my photoresistor I'm going to tie to the +5 rail, or the positive rail. So I'm going to just run a wire from there to the +5 rail. I'm going to change that to red because I feel comfortable with red being positive. In addition to going to ground through that resistor, I'm also going to attach this to the analog in pin 0 on my Arduino. So analog means it's not digital. It means it's not just 1 and 0. And analog inputs can range from 0 to 1023. That'll be important later on. So I'm going to just attach any one of these holes to pin A0 on my Arduino. Make that green. And I'm going to just bend it out of the way a little bit so it's easier to keep track of how everything's connected. Alright, so this is going to be an input into my Arduino. It's important that this side of the photoresistor be attached to ground, because if the photoresistor is getting a 0 value, that should actually be a 0. It should actually be ground, or the negative rail. It's also important to use a resistor to do that, a pretty large resistor, because we don't want to overpower the signal that's coming into the Arduino. And remember, resistors in series with devices divide the voltage down. Next thing I'm going to do is drop my buzzer on. This is called piezo in Tinkercad. It's a piezo buzzer. I'm going to attach one side of my buzzer to pin number 8 on my Arduino, digital pin 8. So from there to there, I'm going to make that connection. I'm going to make this yellow. The other side is just simply going to excuse me. The other side is just simply going to be grounded. So I'm going to attach from that pin to a ground pin on, actually to the ground rail on my breadboard, because this is all going to be grounded. I'm going to change that black because black means ground to me. One other bit of wiring to do. We have to just give our breadboard power. So I'm going to attach +5 volts to the positive rail. I'll turn that red because red means positive, usually. And bend it out of the way a little so it's clear how everything's connected. And then ground to the ground rail. So I'm just going to use this connection over here, use that ground because it's closer, maybe. And I'm going to turn that black because I usually use black for ground. Alright, so everything is attached, and now it's time to write some code. So we're going to do some what's called initialization code before setup. So what we're going to do is define some variables here. We're going to use for 3 of these variables the variable assignment or definition int. Int means it's going to be an integer value that'll be assigned to these variables. The first one is going to be called sensor value. Sensor value. And if you're reading your instructions, what that means is that this is the value that's going to be read at pin A0 based on the voltage that's coming from the photoresistor. Next, I'm going to use an int again, and this is going to be a variable called sensor low. This is a variable that gets used in calibrating our photoresistor so that we know how much light is present in our ambient light. And I'm not just going to define this, I'm also going to assign it a value. This is actually pretty important, and I forgot to put this in the instruction sheet originally. We're going to give this the highest possible value that it could have, which is 1023. Now, even though this is called sensor low, there's a reason for this. We'll talk about when we start writing the setup. I'm going to do an int for another variable called sensor high. Sensor high is going to be the highest possible value, but I'm going to originally set it to the lowest possible value, which would be 0. One more variable. This is a variable that we don't want our code after this line to be able to change, so we're going to make it a different kind of int. It's going to be a const int. So const int means this variable can't have its value changed. The name of it is going to be LED pin, and we're going to give it the value, assign it the value 13. 13 is the pin that has the built-in LED, and that's why we're choosing that, and we're giving it the name LED pin because there's an LED attached to pin 13. Okay, now setup. In between my curly brackets in setup, I'm going to put a procedure for calibrating that photoresistor. So the first thing that I'm going to do is I'm going to turn on the internal LED so that when I'm running this program, I know that I'm in the setup mode and I'm doing calibration. So that's going to be a digital write and I'm going to digital write LED pin, and I'm going to write it high. So that turns on the internal LED and lets us know that we are now entering calibration. Then I'm going to put what's called a while loop. So I'm going to say while, and then here's a test for while. Millis is a command that just says how many milliseconds. So, and I have to open and close parentheses after it. Less than 5,000. So what this command is saying is, or what this line is saying is, do the stuff that comes next as long as less than 5,000 milliseconds have elapsed. So for 5 seconds, it's going to continue to do the little loop that's inside this while. Just like a if, this starts with a curly bracket and ends with a curly bracket. So the things that are inside these curly brackets are going to be done for 5 seconds. All right, the first thing is we're going to read the value coming in from the photoresistor, the value of voltage that's coming to analog pin 0, pin A0. So how we'll do that is we'll assign a value to sensor value. So we'll go sensor value equals analog read, got to capitalize the R in read, and then A0. Okay, so what this is doing is it's saying go to pin A0 and read the value that Arduino will kind of quantify as a value from 0 to 1023. I spelled sensor value wrong, so I got to fix that. Then, here's what it's going to do with it. It's going to check that value against sensor value, sensor low and sensor high. So here we're going to use an if. We're going to say if sensor value, that value that we just read, is less than, sorry, it's greater than sensor high, which of course it always will be at the beginning because sensor high is set at the lowest possible value. Then here's what we're going to do. So we open a curly bracket, and if this is true, if sensor value, the red value, is higher than the set value of 0, then we're going to change the value of sensor high to whatever sensor value is at the moment. So then we'll say sensor high equals sensor value. And then we'll close that line with a semicolon. And that's the only thing we're doing in this if. So I'm going to close my curly brackets. Then I'm going to do another very similar if. So I'm actually going to copy and paste this. But now I'm going to say if sensor value is less than sensor low, not sensor high, but sensor low, which of course it will have to be at the beginning because originally sensor low is set at the highest possible value. Then, if that's true, sensor low will be assigned the value sensor value. So what this does is for 5 seconds, it looks at the value coming in, the light value that's coming in, and it continuously adjusts sensor high up to the highest value that it will get from the highest light, and sensor low it will adjust down to the lowest value that it'll get. So it kind of tunes our photoresistor to the kind of light that's in the room. Okay, so we're now done with that if. And that's the last thing we have to do in the while. So we're going to close the while by putting another curly bracket in there. And then the last thing in setup is we're going to tell ourselves that we're done doing this calibration thing by turning off the LED pin. So this is going to be a digital write of LED pin to low. And that's the last thing we'll do in setup. So setup is basically find a calibration for our photoresistor. Let's go down to loop. Okay, so loop is not really complicated. The first thing we're going to do once we start loop, we're done calibrating, is we're going to read the value that's coming in at pin 0 from our photoresistor. So this is going to be sensor value equals analog read pin A0. That's the first thing we do. Read pin A0 and assign whatever its value is to the variable sensor value. Now we're going to define another variable. This is int, so it's going to be a integer value, and the name of the variable is going to be pitch. And we're going to assign it a value using something called a map. So here's how this works. I type the word map and then open parens. So in map, I'm taking a value that will have a low range and a high range, or a range, a low value and a high value, and I'm mapping it onto a different low and high range. So I'll try to explain how this works as we go here. So the value is sensor value, so just sensor value. That's our variable that we just read. The lowest possible value of sensor value, whoops, I spelled it wrong, put that R in there. Lowest possible value of sensor value is sensor low. So I will put in the word sensor low, that's the variable name. The highest value that sensor value could have is sensor high. So it's locating sensor value in that range of sensor low to sensor high. Now after this comma, I'm going to give the low range of the output that I'm mapping to, which is the lowest possible pitch that I want my buzzer to produce. And that's going to be 50 hertz. So I'm going to use 50 there. 50 hertz is about as low of a pitch as human beings can hear. And the highest possible value of output will be 4,000 hertz. So I'm going to put 4,000. and then I will close this line with a semicolon. So what this is doing is it's reading the sensor value, and it's finding where is it on the range between sensor low and sensor high, and then it's going to proportionally fit it onto a range between 50 hertz and 4,000 hertz, and call that number, whatever that number is between 50 and 4,000, it's going to assign that value to this variable pitch that we just defined. The next line is going to just make a tone on our buzzer. So we're going to use a command called tone, open parentheses, and tone wants to know three things. It wants to know, where do I send this tone, this variable buzzer pitch? What tone do I send, and how long do I send it? So the tone is going out to pin 8 because that's where our buzzer is connected. So I'll put 8, comma. The tone it's supposed to send is whatever is the value of pitch. So I'm going to put in the variable pitch. Gotta spell it right. And how long? Well, I'm going to play it for 20 milliseconds. So I'm going to put a 20, and then I'm going to close that paren and then finish my line off with a semicolon. So what this is saying is, once I figure out what the pitch is supposed to be, I'm going to send that pitch on pin 8 for 20 seconds. Okay, last line, I'm going to wait for 10 milliseconds. So I'm going to put in a delay, 10, and then that will start the loop again, which means it's going to then look for a new value of voltage coming from the photoresistor and then adjust the pitch based on that. Okay, I'm going to click Start Simulation and see if I have any mistakes. So far so good. I'm going to click on my photoresistor, and now I can change the variable, the value of light here by just sliding the slider back and forth. And I remember I get 5 seconds to do this, so I just got to make sure that I, in this 5 seconds, hit the high and the low value of how much light is being added to this simulation. Simulator's running really slow here. I may edit some of this out. Okay, our 5 seconds are about over. If we watch the little LED, it's off now. And now the buzzer is going to respond to how much light. So as I restrict the light, the pitch gets lower. As I add more light, the pitch gets higher. And that's how this works. Good luck.